Hi there. Now here we have a question on areas for polar curves. And what I've got here is just to remind you that the polar curve C is r equals 1 plus tan theta. And you'll notice in blue here I've written the coordinates of P, which we found in the previous part of this question to be 2 and pi upon 4. So if you'd like to read this question through, haven't had a chance to do so, just give you a moment to pause the video, and when you come back you can compare your work solutions to mine. Okay, welcome back then if you had a go. So we've got to find this area R then, bounded by the polar curve and the two lines OP and OQ, and we're told that for OQ the angle theta is pi upon 3. So how do we find areas bounded by polar curves and two lines like this? Well, you should be familiar with the formula. That is that area is equal to half the integral going from one angle, let's say we call this one here theta 1, to the other angle here Q in this case, which is theta 2. So you're going from theta 1 to theta 2. And it's r squared times d theta. So basically, should be familiar with that formula. If not, do check out my video tutorials on this. So what we've got then is half times the integral of r squared. We know that r is 1 plus tan theta, so that's going to be 1 plus tan theta all squared integrated with respect to theta. And theta 1 will be pi upon 4. Theta 2 then is pi upon 3. But I'm going to leave those out because I haven't really got much space here to put those in. We can put them in later, so I'll just label it theta 1, theta 2. So we've got to integrate then this expression. So what we've got then is therefore the area R is going to equal a half. And first of all, we need to expand it out. So expanding out the usual way, you're going to get 1 plus 2 tan theta plus tan squared theta. And that's all integrated with respect to theta. Again, between those limits, theta 1 and theta 2. Now, 1 plus tan squared theta, we should be familiar with, is sec squared theta. So what we've got here then is the integral of sec squared theta, and then 2 tan theta, that's a fairly standard integral, so we'll just leave that in for the moment as that. And put in those limits there, theta 1, theta 2. So let's leave the half out the front there, and we can integrate sec squared theta, that's tan theta, and then, as I say, you should be familiar with the standard integral for tan theta. It's the natural log of sec theta. So we've got 2 times the natural log of sec theta. Let's just put that in brackets there, okay? And then we've got that between the limits theta 1 and theta 2. But theta 1 now we'll just write in as pi upon 4, and theta 2 was pi upon 3. So it's just a question then of substituting your values in, and if you put them in, you should find you get root 3 and then plus 2 times the natural log of 2. Let's put that in brackets there. Minus, and then you've got 1 plus 2 natural log root 2. And we should be looking towards the form that we've got to give this in. We've got the half at the front there, that's fine. And then next up is a natural log. So grouping those and just using the power rule, so you've got natural log of 4 plus the natural, I should say minus the natural log of 2 is going to be the natural log of 4 divided by 2, which is natural log of 2. And then for the other terms, it's just going to be root 3 and then minus 1. So you got it in that form there. Okay,